So here we have an alternative definition of the slope. Let h be x minus a. That is, x is a plus h. All right. So in other words, you want the slope of the secant. So let's zoom in so you can see better. A plus h. So when you take some h distance away from a, you get x coordinate a plus h. Its f value is the y coordinate. So you are now looking at f of a plus h minus f of a, the whole over x2 minus x1, that is simply h. All right. So these are the slopes of secants. So how does the second coordinate get close to the first coordinate? As h approaches 0. Okay. As h approaches 0, you are taking the limit f of a plus h minus f of a the whole over h. That is your second definition of slope of the tangent line. Okay. Now, velocities. Some terminology. In general, suppose an object moves along a straight line according to an equation of motion s equals ft, where s is the displacement, that is directed distance, okay, of the object from the origin of time t. The function f that describes the motion is called position function. Okay, position function is basically at time t whether you want to see whether a, a the particle moves forward, backward, and so on. So it takes care of or records the position of the particle. In the time interval from t equals a to t equals a plus h, the change in position is f of a plus h minus f of a. Why f? Because that is the rule by which position is determined. Okay. So here is 0 and here is s. Forward and you're going back would be negative, so on and so forth. So here is time t equals a. Here is time t equals a plus h. So that's the distance. I shouldn't say distance, but difference in the positions. So f of a plus h minus f of a. All right. What is average velocity? It is the displacement over time. F of a plus h minus f of a over h. So this is what we would call for a curve slope of a secant. So average velocity, think of it as slope of a secant. Displacement over time. Now suppose we compute the average velocities over shorter and shorter time intervals, a to a plus h. In other words, we are letting h to go to 0. Okay, that is called velocity. Velocity is the instantaneous velocity. That is, you are taking limit as h approaches 0. In other words, you are looking for at an instance. Velocity at an instance is the limit of these average velocities. Okay, that is, velocity at time t equals a is equal to the slope of the tangent line. Example, suppose that a ball is dropped from the upper observation deck of the CN Tower, 450 meters above the ground. What is the velocity of the ball after 5 seconds? How fast is the ball traveling when it hits the ground? Okay, so that's a standard question from physics. Well, we need to find the velocity when t equals 5 and when the ball hits the ground. So it is efficient to start by finding the velocity at a general time t. Now, equation of motion is given by ft equals 4.9 t squared. So you are looking at velocity function is limit h approaching 0, f of t plus h minus ft over h. So you are going to plug in t plus h where you see t. So replace t by t plus h. Remember the parentheses, because you don't want to only square t or square h. You want to square t plus h. 4.9 t plus h quantity squared minus f of t, which is 4.9 t squared. When you open this out, you get t squared plus 2th plus h squared. Okay. Then minus that 4.9 has been taken out common, and you are left with t squared here. So notice the t squareds go away. You are left with this quantity. Okay. You can get the h out and get rid of the denominator. You got the h out, and here is the denominator. They cancel. All you are left with is 4.9 2t plus h. When h approaches 0, this guy goes away. H becomes 0. Then 2 times 4.9, 9.8t. So the velocity after 5 seconds, well, all I have to do, so this is the velocity function. So plug in 5 and you get velocity after 5 seconds. What about the velocity when it hits the ground? Well, remember the observation deck. It is 450 meters above the ground. So the ball will hit the ground when the position is 450, that it has covered the entire 450 meters. So position is 450. 4.9 t squared is 450. Solve for t. Divide both sides by 4.9 and then take square root. That is approximately 9.6 seconds. So at that time, the ball has hit the ground. Question is, what is the velocity at that time? Velocity at that time, you just plug it in. You plug it in, approximate answer 94 meters per second. Okay. So we now come to derivatives in our next video.